Today we're going to take a look at solving equations using a calculator to get the answer rather than do it algebraically, as well as looking into domains and ranges of functions. In our first example, we've been asked to solve this fourth degree equation here, and in this case it would be a little bit difficult to do algebraically because we'd have to be able to factor this equation, and we don't really have the tools to be able to do that. So what we're going to do is we're going to take and find out how to graph this using a calculator. Fire that up, and we're going to want to go to our y equals screen and graph this. So in this case we have 4x to the fourth minus 2x squared minus 4x minus 19. And then what we're also going to do in order to graph this is we're going to graph the other side of the equation, where y equals 0. And we did this before a little bit with intercepts, but we can also do this when we're trying to find the equation, because what's going to happen is I'll get a graph of the top equation and a graph of the bottom equation, and I want to find out when those two are equal. And whenever they're equal, they have the same y value for the same x coordinate. So now I'll take and graph this in our standard window. So let's go to zoom, hit number 6, so we're all graphing in the same window. And here's what I see. And it looks like I have two intersection points. And notice you won't be able to see y equals 0 because that's just that horizontal line. I want to find this intersection here and this intersection here. So to go about doing that, we'll repeat the steps we did for our intercepts in our last lesson. And I go second, calculate. I want to find the intersection, so I'm going to hit 5. And then I want to find the blinking cursor, which I can't see right now. Now it appears to be at 0 and negative 19. I want to bring it over to this point, so I use my left arrow, and hopefully that blinking cursor will appear. There it is. I just want to get it close to our intersection point and hit enter 3 times. 1, 2, 3. What it'll do is it'll find that intersection point. So the first x value, where these share a common point, is negative 1.44. And then we're going to once again go back and find the second intersection point. Hit second, calculate. Going to go to the intersection function, which is 5, and we're going to move this cursor from this area over to the area on the right. So I just keep going right until I see that cursor reappear. You'll notice it's continuing to creep up and down. And there it is. So I'm going to hit enter 3 times again. And you'll notice that's at 1.67 roughly. And those are the solutions to that curve. In our second example, there's a couple of different ways to solve these things. What you could do is you could set this first equation to y1 and the second equation to y2 and solve those, but I'm more of a fan of setting aside equal to 0 and then finding the intersection because it appears nicely on your home screen. I'm going to leave the x squared term positive, so I'll set the left side equal to 0, giving me an x squared minus an x plus the root of 3x, and if I subtract 4 from that side, I get negative 14. So again, I'm going to call the one on the right y1 and the one on the left y2, and then find the intersection of those two curves. So let's go back to our calculator, go to y equals, and delete this first guy out, or actually clear it, probably better. And now I'll type in my new equation of x squared minus x plus square root. So here's my square root button in blue. And notice you'll get a parentheses. You want to put the whole 3x inside of there. Close those parentheses off. And minus 14. So now once again we're already in our standard mode. I'm going to hit zoom 6 and look to graph that. And it appears that we're only going to have one intersection point. I could blow this up a little bit and make it bigger. Why don't we do that, and I'll show you how to do it. I'm going to adjust my window. So I'm going to double the size of that to see if it ever comes back up. Hit window. And instead of going from -10 to 10, I'll go from -20 to 20 on both the X and the Y axis. So now my window is going to be kind of double the size on both the X axis and the Y axis. I'll take and graph it again. And you'll notice it still only appears to intersect in one spot. So now I'm going to find that intersection point. Go to second, calculate. Once again. And hit intersection. Get my cursor roughly close to that point. And hit enter 3 times. And that should get me the intersection of the two, where X is 3.79-ish. Approximately 3.79. That's how you use your calculator to go ahead and solve some equations when you can't easily factor or solve. So we've got some definitions for you. First of all is a relation. Relation is basically a set of ordered pairs. Ordered pairs are basically X and Y coordinates. The domain is all the defined values of X's. And when we talk about defined, any X value that makes the equation make sense. Defined Y values are given as the range. And if we want to talk about a relation being a function is a relation such that for every Y there's a unique, or sorry, for every X there's a unique Y. Now, if we want to find the domain and the range for each of these are each sets of points. So the domain in each case is the X value, and the range in each case is the Y value. So the domain is the set of the following points: 4, 8, and -5. While the range is a set of the Y coordinates, or 3 and 2. Now what we want to do is we want to determine if this relation is a function. The way I typically do it is I'll take and plot those out. Here's 4, 3 roughly, 8, 2, -5, 3. And if after graphing my function, I find that I can draw a vertical line through any place in my graph and only touch my function in one point, it's going to be a function. So this is a function. Now in this case, I have a domain being the set of 3 and the range being the set of 4, 5, and 6. And again, if I were to take and graph these, here's 3, 4, 5, and 6. And in this case, you'll notice if I draw a vertical line, it happens to cross through 3 points at one time. Therefore, this is not a function. And this method is called a vertical line test. Next, we want to determine the range, or actually the domain of this function. So the domain talks about the X values that satisfy this equation. Well, sometimes when we take and find a domain, it's much easier to state the values that will not make this function work. So in this case, we notice that we have a rational expression, or in other words, a fraction. And we know when we're talking about fractions, the only thing that fractions don't like is to have denominators of 0. So I look at this and I say, well, when would this denominator be 0? Well, I can simply set it equal to 0 and solve, even though we can probably see that pretty cleanly just by looking at it. I notice that when x equals 4, my denominator, or when x is equal to negative 4, my denominator is 0. Therefore, the domain are all x's not equal to negative 4. Every other x will yield a y answer. When we talk about finding the domain of a function that has a radical in it, again, it's probably easier to state the values that don't work than the values that do work. But in this case, we know that square roots don't like to be negative. So if we find all the values that make that square root positive, those are in the domain. Likewise, we can say any numbers that make that square root negative, we can say are not in the domain. I'm going to go with setting what's ever under that square root to something greater than or equal to 0. That will ensure that I have y values as my answers, or else I have terms in my domain. So in this case, we've got 2x greater than or equal to 7 of the negative type, and take and divide by 2, we get x is greater than or equal to negative 7/2. Anything greater than negative 7/2 will yield a y value, and thus make that function defined. So this is my domain. Let's take a look at the domain of this function. It's fairly similar to the last function, except for the fact that I have an x squared in my radical. Now you'll notice that an x squared is going to make every term in this equation positive. So in essence, what's under the radical will never be negative. Because of that squared value. So we can actually just look at this and state, well, if what's under the radical is always going to be positive, then all numbers will yield a y value. Therefore, my domain is all real numbers. Some more terminology for the day. We talk about dependent variables. Those are typically our y's. Independent variables typically are x's. An implicit form is basically where I have my x's and y's all on one side of an equation. Where an explicit form, I've solved for y, or I've put something in a function notation. Remember, y is the same as f of x. This is just function notation, and this is in explicit type form. All right? So if I want to take and evaluate some function, there are two ways that this can be written. If I want to find the value of y when x is equal to 3 and y is equal to 5x minus 6, well, that's as simple as taking and making that substitution. So I've got 15 minus 6, which is 9. Not a problem. Well, the way we ask that same question in function notation is we say evaluate f of 3 if f of x is equal to 5x minus 6. And this is the same problem. F of 3 is the same as taking this value and substituting it for x. So I've got, once again, 5 times 3 minus 6, or 9. One's in function notation, one's not. Nothing to get worried about.
Now in this example, we have actually two functions, one f of x and the other g of x. And we're asked to do a couple of different things. One is to take f plus g of x, which is basically letting x equal x and then adding the two functions. So if we add f and g, another way to say this is f of x plus g of x, then we get the value of 2x plus 1 added to 4x minus 9. We can add like terms, giving us 6x minus 8. And then when we're asked to find f divided by g of 3, this is saying take the two functions and divide them and evaluate that value at 3. So if I take f of x and plug a 3 in, I get 2 times 3 plus 1. And in the bottom, g of x, 4 times 3 minus 9. This is 6 plus 1 over 12 minus 9, giving me 7 over 3.
That's all we've got. Fill out the summary form, answer the questions on My Math Lab, and we'll see you tomorrow.